Okay, I think we're live. Great. So let's go ahead and get started. Welcome. Welcome to our engineering REYES session. My name is Oscar Gonzalez. I'm the department chair for the electrical and computer engineering department at Old Dominion University. Today, this afternoon, it is my pleasure to introduce to you Professor Hamid Issazadeh. He is a professor with us. He received his mechanical engineering degree from Clarkson University in New York. His interests are in manufacturing engineering. He's got a special interest in welding, manufacturing, and 3D printing. As I see a little 3D printer right behind his left shoulder. So Professor Issazadeh, you're ready to start. The floor is yours. You'll be able to present, and then afterwards I'll ask you the questions that the audience has.
Great. Yep. Thank you. Welcome to this presentation. My name is Hamid Issazadeh. Last name has two parts. We could make it two, Isa and Zadeh. Zadeh means son of Isa. It can, that little things can be added to any, name. For example, I can add that Zadeh to Hamid, make it Hamid Zadeh, or I can add it to Askar Zadeh. It's like, McDonald. We have McDonald here means, son of Donald. This is reverse. The Zadeh went after, but Mc came, before. Just a little introduction. So if you have a little difficulty to pronounce or know what the family name is, so it can be helpful. I got my PhD in mechanical engineering department from Clarkson University. Clarkson University is located in New York, near Canadian border. It's cold up there, 6 month winter. If you like a cold season, cold weather, you should go there. And also this weather, the Hampton Road, I like it because we have 4 seasons. But over there, you most likely you get a 2 seasons, cold and a little spring. Today, I'm gonna be talking about my experience, what I do at the ODU, the courses, and the laboratory that I run in this college. I've been, I joined ODU 2018 and joined, engineering technology department, and I'm in the mechanical engineering technology program. I run 2 labs, 2 laboratory. One is welding, the other one is a material testing laboratory. I teach normally these courses, as you see in this slide, MET 200, material and manufacturing processes, and MET 405, this is a senior level course, Introduction to Welding Technology. And a new course I developed here at ODU, it's called 3D printing. Then it gets a new name, a number. It wasn't in this department before. It will get a MET 406 number. And the other name of 3D printing is Additive Manufacturing. If you have any question about these labs, about these courses, you can contact me through this phone number, and as well as the email. First, I have 2 questions here. Why I became an engineer? I chose to be engineer because I thought it is going to be a lot of fun, And it is a lot of fun, right? You see behind, we are making parts. You can imagine, what you want to do, and then you can make it. You go to laboratory and you have something in mind, and then you, with the tools you have in the lab, you can, make that part. The engineer in the society is called the wizard, right? Because they can use magic to create, things every day. So you think about something, and then you can make it. Especially these days, we have a lot of, good tools, a computer, technology. All this thing can be used. You can have all these devices in your garage and make things. It becomes very, easy these days compared to, for example, 20 years ago. And the other, why ODU? Because we have, various engineering major, depending on your topic, your interest, you can, pursue that engineering. We have, electrical engineering, we have mechanical, we have civil engineering. So today I'm gonna look at some of, the courses I teach here. And if you have any question about this topic, whenever, jump in and let me know. The first one is going to be manufacturing. The next is welding, and the third one is going to be 3D printing. The last one is the material testing lab. This is, a new responsibility for me, material testing laboratory. What is manufacturing? The word manufacturing is coming from two Latin words, manus and factus. Manu means hand, the factus means, make. So you can make, things with the hand. You see this picture, there's a slide. The part comes from, in different shape, and there are, machinery, right? Tooling and power. You need, and definitely power and labor. And depending on the process, this part can be transformed to one or, different shapes for different application. In MET, the manufacturing course that I teach here, it covers different topics where I talk about first different material, polymer material, ceramic material, composite, metal material, and how we can transform these material into different shape. So far, we didn't have, a big lab, but since I think 2019, we have a new space that a student can go and make things. I give them a project where they can make a assembly or a machine in a group. For example, this is one of the projects. Normally, I give my students, it's called triple air engine, where a group of students, 5 students, can make this little parts, and then they can assemble them, and then we can attach it to air, and then it will run by itself. This is one of the projects I would give the my MET 200 student to conduct, to get manufacturing a skill set. The next course is welding technology. It is called MET 405, where a student learn about various welding processes. And in the welding lab, I have three, maybe four, welding machines: stick welding, MIG welding, TIG welding. These are some of the common welding processes that are available in the market. And welding is important because in every industry you need it. For example, space shuttle, without welding, it's not possible to make this monolithic, part, right? It's a big structure. We cannot make, single part from any of, the manufacturing processes that are available right now, unless we join, the parts, a small part, and make them, big part like this space shuttle, right? And welding is very important for in this industry. Also, welding can be used for other, industry, bridges, constructions, for ships, everything. The topic that I cover in the welding technology course are going to be various welding processes, fusion and solid state welding processes. Some of the topic I mentioned, arc welding, stick welding, TIG welding, and MIG welding. I talk about, how material are going to be selected for, these various welding processes. Show them the guideline for the welding processes, how to examine whether the parts were welded correctly, and also welding, symbols. The problem I was facing in this course was that because the nature of the welding is a little, harsh, right? We are dealing with high temperature and a lot of light. So a student might be intimidated, if they didn't have any experience before. What I did was that I requested a machine which is called Augmented reality welding system, where a student can get welding experience before, without performing actual welding process. So this machine shows you how to keep your hands in the proper angle, and how fast you should move your hands. As you see, I was wearing that helmet. That helmet is connected to that machine, and I see this picture inside the helmet, and shows me, gives you a real life example. You can actually see this. You are doing actual welding process, and if you're close, too close plate, the machine tells you that you're not performing correctly. It gives you error. So then you have, based on that feedback, you have to adjust, the angle, or the distance between the torch and that plate. After doing several times, welding with this machine, when I see, because on the machine everything is going to be recorded, the weld pad, the speed, the distance of between the torch and plate, whether it was correct or it was incorrect. All this feedback will be recorded, And then when I see a student have a good, exercise, good practice, then I let them to do actual welding process. Without this, it might be, difficult for a student because they might be, disappointed because it is a little, harsh environment. But once you get some practice with this machine, it becomes like this. It will be easy to adapt actual welding process. And this machine is designed for 3 processes. You can use, you can practice the stick welding, MIG, and TIG welding process in this machine. The next topic is 3D printing. Probably you heard 3D printing, before, but now broadly is known as additive manufacturing, where the part is going to be made layer by layer. Today I was thinking about to make a part for my camera, how to mount my, I got a new camera for research, and there I didn't have a good, holder for that, camera. What I did, I designed a part in a program. We have different type of program, for this purpose. One is Inventor. We have SolidWorks. You can use this, program. They have a free version for students. Inventor. You can use it for 3 years without any payment. And I can write it, later in the chat box. It is a part of Autodesk company. Then I designed it in the Inventor program. Then I send it to this printer. This is a 3D printer, and I made that part this morning. Right, this. So if it was 20 years ago, I'm sure it would take at least a couple of days to make this part, because you have to buy the stock, right? That part, and then send it to machine shop, or some places to cut the part for you, right? But now, while I'm sitting in my office, I can make a part, without any problem. It's less than a couple hours, right? This is the beauty of 3D printing. There are, but remember, there are many ways to make a part with this technology. I'll talk about some of them in the next slide. These printers, a couple of years ago, they were expensive, more than $1,000. But now you can get a 3D printer, maybe around $200, and you can put it. It's about a textbook, right? Textbook is $100, $200. This is the less than $200. You can put it in the garage, whenever you need a part, then design it in the Inventor, and then send it to this, and it will make it for you. Also, I made this part with a 3D printer. You see this airplane? It has several pieces, as you see, because that 3D printer, this is a tricky part, because the 3D printer is limited, the size is limited, right? But how can we make this big part with that printer? What we can, any idea? You can type in the answer in the chat box for it. How can we make this big part with this small printer?
Don't be shy. Go ahead and answer if you can.
I'm not seeing any answer, but the okay, I give you the answer. So we can, instead of making the whole printing the whole part with this 3D printer, we can split it. We can make it a smaller part and then assemble it, right? So that's one trick to make a big structure with this small 3D printer. Does it make sense? Okay. In my course, I had a question, somebody asked about metal printing. I have experience. I'll talk about it. I'll take a note.
I'll remind you of it.
Oh, okay. Thank you.
That's my job.
In my course, I had my student to use this technology to make part. So it was their decision to make part. Any part that they like, and they could optimize it, right? For example, I told them I'm gonna make a coat hanger like this one, right? The right top one. So that was initial idea. But the one problem is that we are using a lot of material on that one. There was another program that I explained my student how to use it and how can they optimize the part to save material, but they don't lose, functionality, right? So they use that program, and they realized some part of that parts, this area are not in, in use, so they don't get any load in that area. So if the part doesn't get a load, then it's not necessary to keep it. So that the programs tells us whether that which area of the part is important, which area we don't need it. So we remove that portion. You see this area and this area was removed. So this is optimization. So this technology, 3D printing, if you have a more complex part, it's going to be easier for it to to fabricate. But if it was traditional manufacturing, for example, the machining process, CNC, this is a computerized, machining. Those type of manufacturing processes prefer the top one, prefer this type of feature to build, because it would take less machining, right? But for the bottom, it's going to be very difficult for them to fabricate, because you see, the feature is complex, and sometimes the machining process may not be able to perform well. What happens? 3D printing is a good method, because if we use less material, it would take less amount of time for the 3D printer to make that part. As these are some of the parts my student made, as you see, and also I got some feedback from them. They said, it's a good reason, when they took this course, they said it's a good reason to purchase a 3D printer. And some of them, they said it is awesome. And in my 3D printing course, I talk about various technology in this topic. Extrusion AM, where extrusion AM, probably you heard it, and it's the type of printer I have here is extrusion AM, where we use plastic material. But recently there were a lot of actually improvement in this area. Everywhere, every year I develop, I teach this course, I have to add new slides to my lecture, because the technology are improving, fast in this topic. I have to, study and learn those technology and add it to my, PowerPoint, lecture and talk about it. Sometimes I cannot, catch it. Even, extrusion, they are using metal for the extrusion. Normally, extrusion was the designed for plastic, but now they are using it for metal. Powder bed fusion is one technology that is mostly designed for metal parts, where you use powder, and then you have a bed of powder, right? Then we have a power source. Power source can be laser, it can be electron beam, different type, and we melt that powder bed selectively, depending on the structure you want to make. So you melt it, then that melted region is going to be connected to the previous layer. So we repeat this process over and over until we make 3D part. I have no experience in making a part with this technology. We don't have this printer powder bed fusion. One method is called selective laser melting. The machine is called SLM. It is expensive, more than $300,000. I have a collaboration with the university in Alabama, where I requested them to make a part for research purposes, and we made a part, and we tested. We wanted to see the strengths of the part compared with the traditional material, traditional part that were made by machining processes. Also, I talk about binder jetting, lamination. In the lamination, there is one process called wood printing. Not wood printing, actually paper printing, where you can make a part with papers. How does it work? Every technology has its own application. For example, if you make that 3D printed part made of paper, it cannot be used for holding a phone, for example. It is, if you make part with that material, it's mostly designed for map, where you can have a 3D map. See, where we have mountain, where we have, downhill, this kind of thing is designed for this technology. And how does it work? You have a paper, right? So the machine will cut it, with the laser precisely, and then it puts another paper on top of it. And again, cut it. There is some adhesion between the papers. There are different type of adhesion depending on the manufacturer. They use different material binder between them, and so when you put these papers on top of each other, so eventually you're going to make a part made of that paper material. And recently I started a project here with Office of Naval Research, where we want to make a part made of wood material. So the idea was that, an initial idea was that, if you go to the Pacific Ocean, right? In the middle of the Pacific Ocean, we are stuck in a island, right? In the island, we have only, trees, sands, and we want to make a shelter for us, or we want to make, a boat. So is it possible, to make a boat precisely? Yes, we can cut the, trees, chop it into a small, particle, make it, make a powder out of it, right? And then if we are working on this, project, we're gonna mix wood powder with the special binder, and then put that paste into our new printer that we designed here in the lab, and we put it in that printer, and the printer makes any structure for you. It depends. You want to make a bridge, you want to make a shelter, you want to make, for example, boat out of wood, out of tree, right? So this is a new topic, that I just recently started. Naval research that are interested in this type of missions. Excuse me, Oscar, do I have time to, because I have a couple more slides I haven't taught, but I see
you're fine. Go ahead.
How long?
You have, I would say, 15 to 18 minutes total, including the answering the questions.
Okay, so talk about my material testing laboratory, just cover in a couple of slides, and I allow them to have some time to ask questions. So I run a laboratory called the Material Testing Laboratory, which is located in the Kaufman Hall, 149, and this is a small, scale testing lab, which is mostly designed, dedicated for teaching. We do some, research in there, but a little. In that, lab, we have a tension testing machine. We have a whiteboard and projector, for lecture, and it has some space, for about 20 students. And we, in that laboratory, we test different material like steel, aluminum, wood, brass, and copper. Also, we do some civil engineering testing material like Portland cement, wood material. We have an option for distance students, where the labs can be done in a synchronous mode, and the software is called PLE. PLE means personal learning environment, and this is the software as you see in this slide, and we show students how to perform torsion test, tension, compression, even non-destructive testing material. So this is universal testing machine for compression and tension, and we use REYES-STEM, guideline, American Society for Testing Material. Testings are important. Why? Because we want to compare material, right? If we have two material, right? We want to measure their strength. So how can we do it? We have to put it, in a machine that can do tensile test, pull apart the two ends of this part, and it gives you a value, a magnitude, right? So this can be done with this machine, this testing. So for tension, we have some samples. We have to follow the guideline. And these samples, they have a name. I already put the name on the picture. It is because it is like, you know, dog bone. We call it, you know, dog bone specimen. Okay. I wanted to ask you, can you, you know, tell me the name of this specimen? But because I put, you know, the name there, so I couldn't ask that question. So this is another, you know, tensile testing machine, which is a smaller version. But the good thing about this machine is that it can be connected to a computer, and then we can record data. And the next machine is called torsional testing machine, where we apply, you know, torsion to a specimen and then twist it. So that property is also important. We can calculate, we can measure the strength of material over torsion and compare the material together. The next process, the next testing is called the Hardness Tester, where we have different, you know, methods. You know, one is called, you know, Brinell, the other one is called, you know, Rockwell, depending on what geometry you use to perform the test. So this one is used as a spherical shape, and we take that, you know, spherical ball, as you see, and apply a load, certain amount of load onto that, you know, ball, and because of that load, this ball is gonna create some pressure on the sample, right? And we can measure that depression when you unload, when you take that, you know, ball from the surface. There will be some depression on the sample. We measure that depression. Okay, I have a question here. If we have a larger depression, does it mean the material is softer or harder? So if we have a larger depression, it means the material was softer, right? If it you can compare wood and, you know, steel. Steel shows a little amount of depression. Wood shows a larger amount of depression when you apply a certain amount of load in both cases. The other one is Rockwell. As you see, the shape is different, you know, and the amount of load, you know, other equations that we use in this method is different. And so because of these differences, we have different scale for comparison. We also test concrete. We make, you know, we use a gravel, concrete, Portland cement, and mix them and make a, you know, prepare it for a slump test. A slump test measures the consistency of, you know, a fresh concrete, and it see whether that concrete meets that, you know, criteria or not. So we do this test in the, you know, material testing laboratory. Let's go to the last section. So all this testing that we perform in this laboratory are called, you know, destructive testing, right? But we also have other methods where a material or a specimen will not be destroyed. They are called non-destructive tests. And we have visual inspection, we have magnetic particle testing, liquid penetrant. We have other methods like radiography and ultrasonic, where we don't have those two technology in the lab. But these three methods are available. We can perform and show a student how can we characterize the material through these methods. The visual inspection or visual examination is one of the most common methods for NDT. And we follow some procedure, and then we can, based on those procedure and examination, we can find whether the part passed the criteria or not, right? Remember, the different application has different criteria. For example, if you want to make a part, this is a sample that shows welding, right? So at the interface, we have welded area. So one part might be good for a bookshelf, right? It may have some flaws, discontinuity on the surface, but it is okay for a bookshelf. But if you see even a small amount of crack, it does not pass the criteria for shipbuilding. So depending on the application, we have to see that the part is going to pass the criteria or not. So every application has its own guideline and criteria. The next test that we do in the material testing lab is called liquid penetrant, where we want to look at the cracks on the surface of the part. Sometimes when you perform the welding process, there will be some solidification cracking that happens, and we don't see it, with the naked eye until we perform, this liquid penetrant testing. And what we do, we spray a material. It is a visible, it is a fluorescent, dye solution. And what this material can penetrate into even very small cracks. They stay there. Later, we with the cloth, we remove the excess. This red area will be gone with the cloths. But those materials that are inside the cracks, they do not come outside. They will stay there. Then we apply a developer. Developer will absorb those material, those liquid that went inside those cracks, right? And we will see some bleeding on the surface. So those areas shows us where we have cracks. So this is one method to show cracks on the surface, right? What happens if the cracks doesn't have opening on the surface? Is this method applicable? No, this method is only applicable for cracks that are open, right? If they don't have open surface, we cannot use this technique. We have to use another technique. It is called magnetic particle testing. I can stop here. I hope you enjoyed this presentation. If you have any question, please let me know.
Okay, thank you very much, Professor Isazadeh. It has been a good experience. We have been introduced to welding, introduced to topics in manufacturing, and learn more about the fun possibilities with additive manufacturing that is using a 3D printer. Let's start by answering the first question. May a student, of course, students, please go ahead and ask more questions. I also appreciate your attempt to create an interactive session. I should have warned the students ahead of time, get ready to answer questions. They were not used to that. But so let's go ahead, please answer the first question. Talk about your research experience in metal additive manufacturing.
Metal, as I said, this technology is very broad. When we say 3D printing, there is no a single 3D printing process. This is one of them. We have a 7 or 8 category, and even each category has its own processes. In the metal 3D printing or metal additive manufacturing, one of the processes I mentioned is selective laser melting. I had experience with one of my collaborators in another university where they made part for me, and then we tested. Another process of metal 3D printing is that we use welding process to make a part, and it is called wire and arc additive manufacturing. I can show you one part that I made with one of my collaborators. So this is a wire arc additive manufacturing, where we use welding process to make this feature, the top one. This is a plate, right? So we deposit it layer by layer. So these are weld bead, you see there. So manually, it's going to be very difficult. We use a robot to make this parts. And it is useful for some industries where we use expensive material, right? Titanium is one of the expensive material in this engineering field. Boeing wants to get some parts made of titanium. But if you want to make titanium part, you have 2 options. You go with the traditional, or you go with the new technology, additive manufacturing, or this technology I showed you. The older one, the traditional one, so you have to take a stock, bigger stock, a rectangle, then cut it with the machining, CNC machine. So because titanium is expensive, you will be wasting a lot of material. So we don't want to waste material. If it was structural steel that we use in the construction, that would be okay. The material we waste has little value, but titanium has a lot of value, so we don't want to waste it. So in that case, we go with 3D printing. We use welding process and deposit layer by layer. Of course, we need another process, CNC, to make a very smooth surface, but still, we are saving a lot of cost.
Okay. Appreciate that. Behind you, that 3D printer was working before and then it stopped. Did it produce something that you want to share, or?
Yeah, I have to remove it. Yeah, it was. So this is one of the research I'm doing is I made a dog bone shape, so where I can see the property of this part. So we are changing the parameter to see their effect on the strength. So we make we put a little layer under it, so it makes a good adhesion between the part and the plate, the platform, the build platform. So that's why after once the process is done, we need a little post processing where we remove this extra material, and then we have that part.
Very good. Thank you. Is there some classes you would recommend high school, middle school students to take in order to, if they like what they've heard today?
At the ODU?
No, this is before. This we're talking middle school, high school students.
I'm not sure,
Just take more science, take more math.
Excuse me?
I guess you could recommend them to take science classes, and some schools, high schools, do have maker spaces with 3D printers, so
really?
take advantage of that.
Oh, okay. Yeah.
Okay. I don't see any more questions, but so thank you very much for. I think it was informative. I hope everybody appreciated that information. We thank you again, and thank everybody for attending. For those students that are attending this session, I remind you there's one more session today, and then after today there's one more week of radio sessions. So look at the calendar and figure out what is of interest to you. Try to take advantage of it. We are very glad that you have joined us for this session today, and I hope that you will continue to experience more of these sessions. So thanks again, and goodbye. Thanks again, Professor Isazadeh.
Bye.
Kevin, it's all yours.